ever since I started studying earthquakes for my PhD in the late 80s, and ever since I started working on television a decade or so ago, really, I've been interested in one particular story, and that is the seismic hazard threat facing Istanbul. Istanbul is one of the world's great cities. It's a beautiful place. It's got energy, dynamism, and this amazing cultural heritage going back millennia. But it's also got one of the gravest earthquake threats we know of on the planet hanging over it. And that's the interesting thing. And the reason for that is all too clear. It was all too clear in August 1999, August 17th, when an earthquake struck to the east of the city in the area of Izmit in the eastern Marmara Sea, killing tens of thousands of people and destroying blocks like these pancake tenement blocks here. So it's very clear that there's an earthquake threat. The reason for that geologically is because it sits on a plate boundary. Here's Istanbul, just located in here, and what we can see is the green dot is the 17th of the August earthquake that I've just shown you. And you can see that it sits on this fault line called the North Anatolian Fault that runs all the way along this area here. And that fault line is slipping about 2.5 centimetres a year as Anatolia to the south block moves progressively westward into the Aegean against essentially a stationary Eurasia. It's getting pushed that way by Arabia in the east. Now, if those motions were gradual, then there wouldn't be any problem, but they're not. They occur as a series of seismic jumps of earthquakes, really. And we know that because we've got the most remarkable record of earthquakes in the 20th century. It's shown there in this graph. The lower part just shows the fault line, and you can see on there the ages of various earthquakes. And the graph above shows the line along the fault line horizontally, but also in the vertical axis shows the amount of displacement that we have during those events. And we see in the red one is 1939, a big earthquake that struck in the east and ripped along the fault line for several hundred kilometers and got displacements, horizontal displacements, because this is a strike-slip fault, a right lateral fault, of up to 7 meters. So these are huge displacements. It was a big earthquake, but it was in the relatively unpopulated east, and the death toll was a few thousand people. But thereafter, there was this remarkable cascade of earthquakes in 1942, then in 1943, then in 1944, 1951, 1957, 1967, broadly marching westwards towards Istanbul. Now, the trouble with earthquakes is we can't predict them. The science of prediction is just not there, if it ever will be. But we can understand the physics of what's going on, how they prepare themselves. And so what has been done, looking at the stress release and stress buildup, there's a really nice picture of how this fault line works. This is the 1939 earthquake, and you'll see that in the areas of purple is where the earthquake has released the pent-up tectonic stress. But in releasing that, it then adds stress to the two ends. So you'll see the little patches of red at either end. The important one is the one to the west, which is the area that's then going to be the nucleation point for the 1942 earthquake. There is a 1942 one, and that area that was red now goes purple. But there's another area of the red to the west, which is the area of the 1943 one. And we see the 1943 earthquake. And again, the western tip of that 1943 one is where 1944 nucleates. And then the same thing happens produced in 1957, and in 1957 then it causes the stress conditions for the 1967. So it's really no surprise that the area that happened next really was further to the west. But actually, what was surprising, it took 30 years to do it. And so this is the situation that happened in that August 1999 earthquake, 17th, where that area then releases its stress, goes purple. There's an area of red to the east that actually gets filled in November 1999, that same year. So that actually has gone purple. So the only bit of red of high stress left is the bit further to the west in the Marmara Sea. And so this is what we think the story is really. This North Anatolian fault line has essentially all its main segments have essentially gone, have ripped open really in the 20th century, including an earthquake over to the west in 1912. So the only substantive segment of the North Anatolian fault left is a segment right beside Istanbul, and this is called the Prince's Island segment. It's offshore in the waters of the Marmara Sea, and this image shows the kind of bathymetry there, so you can see the escarpment in the seabed, suggesting that when the earthquake does happen, then there'll be submarine landslides and the likelihood of tsunamis, and there's a long record of tsunamis from the Marmara Sea. That segment depends how much of it ruptures, but the estimation is that that is capable of producing a magnitude 7 or even higher earthquake. And the risk is, of course, what lies just a few tens of kilometres further north, and that is Istanbul, Europe's megacity, a city of 13.5 million people. And not just that, some of the most urbanised and industrialised bit of coastline in Turkey. Most of the energy plants, most of the gas plants, most of the traffic and kind of routeways, rail routeways go through this particular area. So this is an area of extraordinarily high seismic risk beside a fault that is waiting to go. After 1999, it was estimated that I think there was a 60% probability of an earthquake magnitude 7 or above in the next 30 years, and that was 15 years ago. So this is about as high as it really gets. And we know it's a city that has lots of earthquakes because the building tells us. This is Hagia Sophia, which is the great iconic building of Istanbul. And unlike many of the mosques you'll see around the city, it's not got the sleek lines of the modern mosque. And that's because you can just see around it, it's got these stone buttresses that's just holding it together. And those stone buttresses are because every time Istanbul gets struck by a large earthquake, bits of the structure kind of fall down. Now it's just getting held up. It looks like a pyramid almost. So actually, ironically, this is probably quite a safe structure, unlike much of the rest of the city, because much of that city you can see there hasn't been struck by a direct hit for many centuries. And so we worry about what the vulnerability of this is. Now, many of the modern buildings and many of the engineered structures, bridges and subways, etc., that's happened over the last decade or so, have been very much built with earthquakes in mind. But in terms of the broader city, of the urban fabric of Istanbul, that's far less likely. And if you go in there, you can see, part of its charm is this area of older buildings. This is a bazaar crammed full of people going through. The likelihood is that with some of the earthquake scenarios, tens of thousands of these buildings will collapse, and that means essentially potential for really quite a catastrophic, calamitous death toll. Now, after the 1999 earthquake, there was what's called a seismic zonation map done by Japanese scientists who came in, and this is a kind of popular version of it. It's published in the press. And what you see in cream are the areas where there is the expectation of very high seismic shaking, and that's because you get the earthquake affecting loose sediment, probably saturated with water, so it amplifies liquefaction. So much more high levels of shaking in these areas. And then also in red, what you see is areas that have been designated by city authorities as at risk from a cultural heritage point of view. So large parts of the city then seem to be threatened by earthquakes. The problem, though, is that if you look at Istanbul in terms of the people, that actually shows very few signs of taking on some level of seismic preparedness. What that means is that in many countries with earthquake threats, people can do certain things. They can take on information about emergency plans, they can have an emergency earthquake pack, they can know what to do, basic education, know what to do in an earthquake. They can start to protect their household in various ways, putting shelves up properly, taking beds away from windows and putting make sure wardrobes are attached to walls, a whole bunch of stuff, knowing where to go in the event of, after the earthquake. But actually the take-up of that information, the kind of preparedness and protection measures that people take seem to be very, very low in Istanbul, and especially low in some of those at-risk neighbourhoods. And to understand why that is, I think it's worthwhile getting into the psyche of the Turkish people. So this is a nice study that's been done by psychologists at UCL in London, and they looked at social representations of earthquakes in Western USA, in Turkey, and in Japan. And what we see, there are some commonalities. So, for example, they all show high levels of fatalism. That means it will happen. There's nothing we can do. An earthquake's going to happen. Of course, it's correct. Another one, interestingly, is high level of awareness. In other words, the messages have got through. People know there's going to be an earthquake. And that's certainly the case in Istanbul. If you talk to ordinary people in the bazaar, they say, yeah, we know there's probably going to be an earthquake. If you swing to the right in this, what you see are some differences. The increase of perception of that God is playing a process here, that earthquakes are somehow acts of God. But I think more importantly, the one right at the end, is that earthquakes as acts of people. And that doesn't mean that people trigger earthquakes. It means that the disasters that's produced have been triggered by people. And we get a little bit more on this if we drill into these kind of values and perceptions a little bit more. It's again from the UCL study. What we see high levels of worry, anxiety, fear amongst all of those populations. But Turkey is distinctive in having a very high level of despair, sadness, isolation, very high level of sense of vulnerability, and a very high level of what's referred to as a demise of identity. And that is a sense of a kind of political degeneration or a cultural degeneration of a country that's become slightly immoral and dysfunctional. That's what comes through from the interviews. And the reason for that we can see on the right-hand side, which is a great perception, very high perception of corruption, a blaming that big business is somehow in cahoots with this whole process, blaming of the state has been ineffective, probably because it's all tied into big business as part of this corrupt kind of system. And that then leads at the end to high levels of distrust and high levels of anger and discontent. And I think what's interesting from my perspective is the question of, well, if you're an earthquake scientist charged with communicating earthquake risk, what do you do in this very contested political environment? This is a pressure cooker environment whereby the actual traditional state authorities that scientists would go through, going through the government, local planning departments and local officials to get the message through, well, that whole system is seen as the problem. And equally on the other side, a skepticism about the press and the media and the use of that. So our two main avenues tend to be kind of taken away. And what you get on the ground is this population that feels at risk, but it doesn't really have anything to, any way to go, any connection into information, because the information is not getting to it. So what interests me is this business about, as a geoscientist, what my role is and my responsibility to communicate earthquake hazard in this environment, and how I get the information to those that need it. And by that, I mean those that are living in those at-risk neighbourhoods. And so it's really reaching these people. It's reaching the public that is the interesting question. How do we do that in this environment? And this really is the reason why a paper we've just published with a PhD student of mine, Johanna Ickert, trying to think about new ways that geoscientists can get their message across to the public, and getting geoscientists to think about what their responsibility is in these very contested environments to make sure that those people who need their information can get that information.